we now look back at grade 11 questions that we would have done originally by finding reference angles and using our calculator, but now they become non-calculator questions if one of the values is something that we know from our unit circle. So, if this question was a grade 11 question, this is what would have happened in grade 11. You could have had this exact same question, but it would be between 0 and 360 degrees. You would have taken out your calculator and, well, you might have first said to yourself, according to the cast rule, if sine is negative, then this answer is either in quadrant 3 or quadrant 4, and this would be my reference angle. And if that's my reference angle and I drew a triangle, since sine is opposite over hypotenuse, I could have labeled this side as root 3, and this is 2, this side is root 3, and this is 2. And I could have solved for my reference angle by doing sine inverse. And since we're actually thinking about that triangle, I would have typed into my calculator sine inverse of root 3 over 2. And your calculator would have spit out 60 degrees as your reference angle. Then your answer in quadrant 3 would be 180 plus 60 degrees. And your answer in quadrant 4 would be 360 minus 60 degrees, or 300 degrees. And that's how you would have done it in grade 11. You would have taken out your calculator and found your reference angle. Now that we're in grade 12 and this is a non-calculator question, what you would instead do is say, hey, I know that root 3 over 2 is on my pi plate. I know that sine is my y coordinate. What reference angle gives me root 3 over 2 as a y coordinate? And since we're dealing in radians, what's my reference angle in radians? So you'd go to your unit circle and say that happens when it's my pi over 3 family. And then when is sine negative? Sine is negative in quadrants 3 and quadrants 4. What are my pi over 3 family members in quadrant 3? 4 pi over 3, and quadrant 4? 5 pi over 3. And this is all the work you need to show. So we don't need our calculator. We recognize the value and find out our reference angle from that, and then just state what quadrants it's going to be in. So we revisit all of the types of questions that we had from grade 11, but now we say if we can recognize a value from our unit circle, we'll use that instead. So here we have cos of theta equals -1. Again, we want exact values. That means that we're going to leave our answers as pi over something. And these would all be non-calculator. So cos of theta equals -1. Do you ever have your x coordinate -1 on your unit circle? Yes. When does that happen? The only place is when the angle's pi. And that's all you'd have to write for this question. Just write down the answer. What about tan equals -1? Well, is tan ever 1 on your unit circle? Yes. What family does that happen in? Pi over 4 family. Now, tan is negative in quadrants 2 and quadrants 4. So then, what's our pi over 4 in quadrant 2? 3 pi over 4. What's our pi over 4 family in quadrant 4? 7 pi over 4. Ooh, I like this pi. Doesn't it look pretty? These ones not. Okay. Secant of theta equals 2. I feel like writing pretty. There we go. So first of all, If secant theta is 2, that means cos of theta would be 1 over 2. Is that on our unit circle? Is our x-coordinate ever 1/2? What family? Pi over 3 family. And then if cos is positive, that would be in quadrant 1. And quadrant 4. Do you like this pen? It's fancy. Again, in grade 11, if you were solving for theta here, first of all, we would need to get sine of theta by itself. Can you see that if you subtract 1 on both sides and then divide by 2, you'd get sine theta by itself? What's our reference angle? Pi over 6. And then sine is negative in quadrants 3 and quadrant 4. Grade 11, you also had quadratic equations. Quadratic equations were like normally with x squared plus 5x plus 6 equals 0, and you'd have to factor to solve them. Well, we'll also have quadratic trig equations. So again, we'll try to factor first and then solve. In this case, we have a common factor, cos squared minus cos. There's a cos in common in both of those. Do you guys know why we factor to solve these? Do you remember why it is that you factor to solve, or you just remember that you need to factor to solve something? Yeah, you just remember you need to factor to solve something. Well, I'll give you an example of why factoring to solve something is so important. We started off with something minus something equals 0. So I'm going to just pick a number in my head. I've got a number in my head minus another number in my head. It's equal to 0. Can you guess the number that's in my head? Take a chance. I've got a number in my head minus another number in my head. It's equal to 0. It's not 1. It's not 57. You could guess for a very long time and probably not get it. It was 3.2. How long do you think that would take? Probably a very long time before you got 3.2. You would have given up and said, this is stupid. But if I change something from just adding and subtracting, if I change it to here to be multiplying, and I now tell you I have two numbers in my head, you just have to guess one of them, and they multiply to equal 0. One of them has to be 0. You can't multiply two numbers together with one of them not being 0 to have it equal to 0. The other one was 7.8. I don't think you would have got that one. But one of them was 0. And that's the power in factoring. Because once you factor it, you've changed it to be multiplying now. And when it's multiplying and equal to 0, that means that one of these has to be 0. And if I draw a line here and I say, well, if the first one is 0, then this is a possibility. If the second one is 0, cos theta minus 1 equals 0, we usually just go right away and move the 1 over, then that's another possibility. And having done that helps us solve our equation. Whereas at the beginning, we might have to guess and check for a long time because we're just adding and subtracting. But once we change it to multiplying, the only way two things that are multiplied equals 0 is if the first one is 0, in this case cos theta could be 0, or the second one is 0, cos theta minus 1 equals 0, then cos theta would equal 1. And from here, we now can solve. Is your x-coordinate ever 0 on your pie plate? When? x-coordinate. And we're dealing in radians here. So pi over 2 or 3 pi over 2. Is your x-coordinate ever 1? Yes, at 0 and at 2 pi. And because we have equal signs with our range there, we would have to include both 0 and 2 pi. Sometimes in your textbook, you'll find they'll have it written like this. Then you would not include 2 pi, because 2 pi isn't included in that answer. But because our domain says from 0 to 2 pi, including 0 and including 2 pi, you would include them both. So that's the power of factoring. Because if we change something to multiplying to equal 0, then it's obvious that either the first factor has to be 0, in which case these are possibilities, or the second factor has to equal 0, in which case those are other possibilities. If you just had something squared, how would you go about solving this? Right? If you just had, if I just had x squared minus 5 equals 0, how would you solve that? Yes. Get the squared thing by itself, yes. Move the 3/4 to the other side, and then square root both sides. Now, when you square root both sides, you have to remember plus or minus. And this is where your algebra skills from grades 9 through 11 come into play. Can you simplify this at all? Because this is non-calculator. And right now, I don't recognize the square root of 3 over 4. But the square root of 3 over 4 is the same thing as the square root of 3 over the square root of 4. And the square root of 4 is 2. Now do you recognize that value? What family has your y-coordinate as square root of 3 over 2? Pi over 6 or pi over 3? Pi over 3. And because we have the plus or the minus, it's where sign is positive or where sign is negative. And so we have all 4 quadrants. And so we have every single family member. We can call this like a family gathering or something. Every part of the pi over 3 family is in this answer. Now test your factoring skills. We have a trinomial, so when we're factoring this one, if you can factor it directly, it'll be 2 binomials multiplied together to get 2 sine squared minus 3 sine theta plus 1. Grade 10 and grade 11, you might have learned multiple techniques for figuring this out. For the most part in grade 12, I'd like you to be able to do it directly. So something I want you to notice when you multiply things directly, and I'll just sort of do something off to the side here. If you were multiplying something out like this, and it was equal to 0. If I expand this, you know that you would have to multiply this times this, and that times that, and this times this, and this times this. And in English, we even have an acronym. You might remember the acronym for multiplying this out, that you multiplied the first ones out, then you multiplied the outside ones, then the inside ones, and then the last ones. So we sometimes use the word FOIL as a verb for multiplying this out. Just as a reminder that you multiply the first ones, the outside ones, the inside ones, and the last ones. When you do that, what do you get? Well, 3x times x is 3x squared. 3x times 2 is plus 6x. Minus 1 times x would be minus x. And minus 1 times 2 would be minus 2. Simplifying this all away, we get 3x squared plus 5x minus 2. Now the question is, if you had to factor, if the question started off with 3x squared plus 5x minus 2, and these are the hardest ones to factor when there is a coefficient in front of the x squared, how could I go from here to here in one step? Or not in one step, but sort of directly. You have to do some thinking, so there might be more steps in your head. But what I want you to notice is a couple of patterns. I want you to notice that whatever your first ones are, always give you your first term. That 3x times x has to give you 3x squared. And whatever your last ones are, see how my last ones are a minus 1 and a 2? They multiply together to give me my minus 2. And every single time that you multiply these together, your outside and inside have to get combined to give you the 5x. So when starting to factor the one that we have here, if I have a 2 sine squared theta, there's only one option for my first terms. Can you see that? That the only thing that I can put for my first terms are 2 sine theta and sine theta. And so when there's only one option, I write that down first. Just like with 3x squared, the only option is 3x and x. My last term is a 1. What are the only options to multiply to get 1? It has to be 1 and 1. Does that make sense? The last thing I have to figure out here is what my signs are going to be. To get a positive 1, they either both have to be positive or both have to be negative. And when trying to figure out whether they're both positive or both negative, you're going to think about your outside and inside getting combined to be 3. Can you see right now that my outside will make 2 sine theta, my inside will make 1 sine theta? In order to get a minus 3 sine theta, they would both have to be negative.
Sorry for the interruption, staff and students. Just before the bell, period 3, we're going to have grade 11 students come down who did not take part in the online registration yesterday, particularly if you have a spare. Could you please head to B4 at the bell? So that's any grade 11 students with or without a spare who did not register yesterday. Please head B2. Thank you.
And so now we can say, well, now that we've factored it, either the first one's equal to 0, and if 2 sine theta minus 1 is equal to 0, that would make sine theta equal to 1/2. That's my pi over 6 family. When is sine positive? Quadrant 1 and quadrant 2. When is sine theta equal to 1? Well, that's part of an axis family. When is my y-coordinate equal to 1? That only happens at pi over 2. So our factoring skills come into effect, and I would, for the most part in grade 12, they don't give you ones that are really complicated. They don't give you ones with starting with an 8, because 8 is bad because it might be 4 and 2 or 1 and 8, right, when you have more than one option. Usually the factoring ones in grade 12, They only have one option for your first ones or one option for your last terms, and you either start with your first or last ones and then work from there to see if you can figure it out. But if you've used grouping techniques or other techniques, you can do those. Just be careful with your notation. Yes? You can switch your signs to x's off to the side, but if you do that on an exam and you don't say let x equal sine theta or something like that, they'll take off a half a mark for introducing a variable without defining it. And if this was sine x, then you can't use x in a different way. Then you'd have to use b or w or r or some other letter. I think with practice, you'll get fine just to deal with sine instead of having to switch it back to x. And I'd like you to get to that point. So practice it already just dealing with sine. Okay. Ooh. I don't know if we have time. This is a pretty heavy one. What we'll do instead, just to see, get you used to factoring a little bit more, I'll put up some other factoring ones, and I want you to try to factor them. So, 1. Just factor. You don't have to solve. Just factor